where we talk about how to balance it, and it is all the things which we come across in day-to-day life, how to balance things so that we work under time constraint. Work under time constraint, we need to balance out how much to explore and how much to exploit, because we cannot keep exploring. Then what happens is that you don't get the best solution, and you cannot keep exploiting, because then you don't land up only looking for few set of solutions rather than all. So you need to keep balance. So whenever I talk about exploration, exploitation, I very give a very real life example about people who visit malls to buy things, because I believe that people always have certain time shortage whenever they go to mall. And whenever they go to mall, they have a time shortage that they can spend 3 or 4 hours or 5 hours in a mall, not beyond that, and they have to buy some item. And many shops are selling those items. And now the thing is that how to buy and how to get the best price for those items. Again, the trade-off is always exploration and exploitation. How? Because you cannot visit all shops because you don't have enough time. If you try to visit all shops, then you cannot do bargaining in each shop, because that is exploitation that you are not going
Sir,
to do.
TV sir,
Yes.
actually this presentation slides are not visible to us.
No, but I
So
have. It is there.
yes, sir.
No.
It was there for
Is it?
few
But
minutes.
I'm not right now referring to slides. I'm just on the first
Okay,
page
sir.
only.
Now it is visible.
Okay.
Yeah.
So what I'm okay. Let me put my video off, because of some internet thing. I should not have any problem. So let me put my video off. Okay.
Yes.
So the issue is that how to have a balance between exploration. So as I was talking about an example of a mall where you go and buy something. For example, you want to buy maybe some sort of any electronic equipment. Maybe suppose a toaster you want to buy in a mall. So many shops are there which sells toaster. Many sort of incentives are there, and there is the option of doing bargaining as well. But then what you do? You can't visit all shops. You can't visit all shops. You can't visit all shops. Then you are actually going to explore without exploiting. But at the same time, if you try to get stuck in one shop and keep bargaining again and again so that you don't get time to visit other shops, then you are exploiting, not exploring. Now the thing is, this balance has to be reached, that how much to explore and how much to exploit, so that you have visited most of the shops, and in each of these shops you have done enough good acceptable level of exploitation. That is some sort of bargaining you have done. So this problem is very relevant in day-to-day life when you talk about exploitation and exploration. You need to explore, because there's so many places where you can buy things. There's so many options that are given to you, but you cannot go through all of them. Even internet websites, when there are so many places where you can buy an item, but if you just try to go to all possible places, it's so difficult to go. But at the same time, when you start exploring some places with sorts of incentives or some sort of a thing which comes with a credit card offers and all, then that is there. So what I mean to say is exploitation and exploration also always needs to be balanced, because you cannot keep exploring. Then you are not going to have an optimal solution. You are going to have suboptimal solution. You cannot keep exploiting. Then also you are not going to have an optimal solution, because you have not explored the search space, because some solutions may lie outside the search space. So the idea of balancing exploration exploitation, now in the research terminology, this exploitation is called intensification, and exploration is called diversification. So this intensification and diversification has to be balanced. So when I say balance, I need to find out the trade-offs, because if you explore too much, you exploit less, and when you exploit too much, you explore less. So there is a conflicting relationship between the two. Okay, so the point is you need to have a trade-off. What is a good enough exploration and what is a good enough exploitation? So whenever I talk about exploitation and exploration, I always work on one area of meta-heuristics. And meta-heuristics goal is to find a trade-off between exploitation and exploitation. So how do you find exploitation? How do you find this thing is another thing. So what I would initially brief out what is in information search, what is retrieval and search, and then what is the problem with them and how do you address using techniques. I will discuss a little bit meta-heuristic techniques, and then I will talk about techniques which are multi-objective, because in real life problems there is no single objective problem, because real life problems talks around multiple objectives which you need to optimize simultaneously. There is no, usually you will not encounter any situation in real life which talks about a single object. Because even buying a car, you have two objectives. You want to have a comfort, you want to have facilities in a car, and at the same time, you want to have them minimize the cost of the car. Now, if you try to minimize the cost, the facility also minimizes, which is supposed to maximize. And if you try to maximize the facility, then you maximize the cost, which was supposed to be minimized. Again, they are conflicting in nature. But then you need to find an optimal trade-off there as well, where you want to buy a car which is of minimal cost, at the same time that has good amount of facility. So whenever you come across day-to-day life, you have to talk about this thing. Now, information search. Now the thing is, why information search becomes a bigger problem is that you have the same information. If you go for a Google search also, when you go for a Google search, you find the same you put a keyword and you get so many results of the keyword. Now, each result may focus on different databases that is available on the internet. But how do you actually try to find out this thing? Now, there was a concept of search engines and there was a concept of meta search engines. Now, there is a meta search engine which tries to identify the search engines, and search engines, every search engine has its own database. So what is the goal of a meta search engine is to identify those search engines which can provide you results. And then once the results are retrieved from those search engines, the next step, which is again a challenging step, is to order them, rank those results. And that is how even the Google is doing. Because when you see Google, you only see 20 documents in a page. But how did they rank those documents from 1 to 20 is a different question altogether. Again, there is a mechanism how thing. There is some topic which we talk about information overload. We always like to reduce this information overload because the thing is, because of this advent of big data and other scenario, a lot of information is getting generated. But then you need to reduce this information overload so that you are able to work with this information which is relevant to you and your needs. Okay? So for me, I will talk about a little bit about information search and retrieval, what the focus is, and how in general such problems are addressed using algorithms that addresses the balancing of exploration and exploitation. So I will just have a brief outlook about these algorithms also. And then at the end, I will talk about usually algorithms are always developed for single objective, how the multi-objective, which is usually the problem in real life of such scenario, how these multi-objective problems are addressed using this. So when you talk about information retrieval, activity of obtaining information system resources that are relevant to any information need from a collection of those resources. Now you try to collect information from various resources. Searches can be based on full text or other content-based indexing. Some sort of content-based indexing may be there, or it can be a full text search. Information retrieval is the science of searching for information in a document, searching for documents themselves, and also searching for the metadata that describes data and for data of the images or sounds. Now, this is what information retrieval will be all about. That you need to search for documents, searching for information, searching for documents themselves, and all this thing. Automated information retrieval systems are used to reduce what has been called information overload, and that is what happens to be the ultimate goal, to reduce the information overload. An information retrieval process begins when a user enters a query into the system. It all starts because when you try to, it's all based on the needs of the user. So user poses a query. Yes.
Sir, TV sir, can make it full screen, sir? Can it make it this screen, shared screen, full screen? We need to make it PPT.
Is it there?
Yeah. Yes, sir. Fine, sir.
Okay. So information retrieval begins when a user enters a query into the system. Queries are some sort of formal statement of information needs, and a query does not uniquely identify a single object in the collection. So queries are ad hoc in nature. Whenever you try to pose a query, they may not be referring to a single object. When you pose a query, Turkey, it may refer to a bird or it may refer to a country as well. Okay. So instead, several objects may match the query, perhaps with different degrees of relevancy. And that relevance is very important. And that is what the challenge of these search engines and meta search engines is, that how do you find which is most relevant and therefore put those documents at the top of the results of it. And that is what the challenge is. So IR deals with the representation, storage, and organization of unstructured data. Now, today we talk about unstructured data. The reason being is that unstructured data is the one which is dominating all sorts of data today. Entire web, mainly most of the data in the entire web is unstructured. So you are dealing with most of the unstructured data. That's why a lot of terminologies were dictated by that. We call web mining. But web mining terminology is actually data mining, because it's when you say web mining, we are actually talking about mining semi-structured and unstructured data. But it is actually still mining the data. But people prefer to call it web mining because most of the semi-structured, unstructured data lies on the web. So they said the most appropriately we can call it web mining. So that type of organization, now the point is to deal with unstructured data, it becomes a challenge because you have so many documents that are available. I is the process of searching within a document collection for a particular information need. And that is based on what the the user poses. User poses a query based on which certain needs are there. Now, interestingly, if you find a keyword, as I said earlier, one keyword may correspond to many objects in many databases. Now, the thing is that how do you combine these objects from various databases and form a result to a query? And in which order you form the result to a query? They have the certain things. There are certain rules in which you want to optimize the output or optimize the answer to the query as well. Because collecting, if the objects are lying in the same database, it is much more preferable to pick them together rather than objects which are dispersed across various databases, because there is a communication cost, there is a cost of integrating that information and putting it as part of the results. Its mission is to assist in information search, that is the IR. The two main search paradigms in IR, one is the retrieval and one is the browse. Retrieval is search for a particular information. That is what we call retrieval. It's usually focused and purposeful. We are looking for a particular information. Browsing is something general, looking around for information. And usually whenever people start saying, they are initially browsing, because sometimes this is what is the exploratory searches all about. This is what the ad hocism is. Ad hocism is in the nature of the query, which is not predefined or priorly known. And there is something called, exploratory search. Initially, we may put keywords in the search, and then we are ourselves not clear what we are looking for. But we start browsing, and then we try to go towards actually what we are looking for. So its browsing is maybe through the navigation of various things like area, Asia, then you go to Thailand, Phuket, and tsunami. So you can browse in this manner through some sort of a navigation links also. Now, information search, because the ultimate goal of an IR system is for information search. We know the World Wide Web has become the primary source of information for leisure and work activities. World Wide Web, huge content would be wasted if that information could not be found, analyzed, and exploited. The thing is, it's not all about whether you want to exploit or not. It is always try to be competitive in a market. If you are able to exploit more and more and present good results to the user, you are going to gain visitors who become users of your system. So when you talk about these websites, the ultimate goal of these websites is to make visitors as users, which is a challenging task. You may have visitors, but still they may not be users. But the ultimate goal is to make them users. That's why, always there is a question whether a website should be informative or entertaining. Now, it's a very interesting question, whether it's entertaining. It has to have, again, a balance of both. Because a website which is informative may not be that exciting for a person to sustain if it is not entertaining. So that's why a mixture of both will always be helpful. Entertaining website, if it is entertaining, it keeps you there. And then if you disperse the information, people tend to understand it. So it's again a balance. You need to make it entertaining so that you sustain users, the visitors of the website, and then provide them information so that they become users of the website. Each user should be able to quickly find information that is both relevant and comprehensive for their needs. World Wide Web has become a principal driver of innovation, and a range of new systems have been developed to exploit this information content. If the system presents only document list, now the question is, what type of information search may be there? If the system presents only document list, that is, it expects will satisfy the user. So that means the system is deciding what information to be fed. It cannot obtain feedback on other potentially better solutions. That means you are restricting the other solutions to be displayed to the user. So you are displaying certain set of solutions. Then what about the other solutions where a user can give feedback? You are not. However, if it presents document list from which it can gain a lot of new information. Now, other angle is that it tries to display a document to you, information to you, and then it asks for feedbacks from you. Then it's likely that you are feeding information that may not be relevant. So results may its risk presents bad results to user during learning. Therefore, to perform optimally, the system must explore new solutions, and while also maintaining satisfactory performance by exploiting existing solutions. And that is where the question is exploration. How much to explore, how much to exploit comes into picture. That how much exploration you need to do and how much exploitation you need to do. Even any trends keep changing. So trends keep changing, the buying behavior keeps changing. So if you have one model for one set of data for a buying behavior, then that model will not last sustain for long, because trends changing, then you need to have new inputs to the system for training also as well. So that new inputs will have that exploratory aspect, and you at the same time you do not forget the ones you have used before for exploratory aspects. So that is how the systems also learn. You keep having exploring and exploiting. So making online learning to rank for IR works in realistic settings require effective ways to balance exploration and exploitation. So when I say exploration, exploitation, how much you are ready to look for objects in various databases, that is exploration. And within those databases, how much you are looking for, to find out how was the optimal way of accessing information from those objects, that is exploitation. If you start exploring, then your efficiency in terms of accessing will decrease. If you start exploiting, then it is possible that you may have missed out a document which is in some other databases, which may have more relevance as compared to this. So that's why, again, I said the balancing of exploration and exploitation is very important. And that is what the meta-heuristics are all about. There are techniques in computer science which actually deals with balancing this exploration and exploitation. Usually we come across heuristics. Heuristics is the way you search for something. But you search, maybe if you have studied, you must have studied hill climbing algorithms. You search for something. You go this way, if you don't find something good, you come back and go the other way around. So heuristic, but you are actually stuck in a local search space, and you are looking for the best way to climb, say, a mountain. Okay, then you try to see how much far you go. If you cannot go further, you come back and take another route towards it. So this is heuristic search. You are actually going. But usually in real life, we do not come across this situation. If I say heuristic search, if I mean in terms of the example I gave in the mall, it's like saying that you are actually trying to work out in a particular floor or a particular shop for looking to buy something. You are not exploring. You are just getting stuck into that place, and you are trying to. You don't want to go around. You want to just buy things at that. But in real life, that is not a good solution, because the point is you may not get a best deal. If you only explore one shop, you may find some other shop in the mall which can give you a better deal. So heuristics is something which you search around for some good set of solutions. But then meta-heuristic is what? People say it's heuristic about heuristic. That is what people meta-heuristic. But when you talk about meta-heuristic, it is heuristic plus some randomization. That randomization enables you to move from one place to another. Suppose I want to go to the highest peak in the entire mountain ranges. Now, if I get into one range, okay, then I'm going to get to the peak of that only. But that does not mean that that is the highest peak. But that randomization, what it will enable you to do is, it will make you jump from one range to the other and look for different local spaces. So what will happen in this, in the analogy of a mall, it will make you move from one shop to another and then look for this. And that other shop is a randomized. Your choice will be in a randomized fashion. So what happens is, you tend to get exploration is by moving from one place to another in a random fashion, and then within those spaces you do a good enough of exploitation, and then you try to achieve. So when you go to buy something in a mall also, you need to understand how many shops you would like to visit, because you have a constraint on time. There may be 100 shops, but you cannot visit more than 10, because then you try to randomly pick all these shops, and that is where the heuristic plus randomization comes. That you pick one shop, you exploit, you do bargaining, and then go to another shop, then you exploit, do bargaining, and then go to another shop. But then that balance of how many shops you visit and how much time you spend in each shop is what is called the exploration and exploitation, and that balance between the two you have to be achieved. And that is the way you try to access in terms of information search also. So now I will be focusing on techniques that enables you to have that balance. How do you get that balance? So I will be talking about meta-heuristic techniques. But what is meta-heuristic? Let me talk about. Now, what is a meta-heuristic algorithm? You know, meta is at an upper level. Heuristic is to find or to search. And when heuristic methods are more deterministic methods, because you are actually going around the local space. Then when you talk about meta-heuristics, you talk about heuristic plus randomization. Some sort of a random movement, because you cannot get stuck in a local optima. So you need to traverse various local optimas and then try to find which is the best amongst the local optimas you have traversed. And that randomization will enable you to traverse you through various optima. So a meta-heuristic is formally defined as an iterative generation process which guides a subordinate heuristic by combining intelligently different concepts for exploring and exploiting the search space. Learning strategies are used to structure information in order to efficiently deal optimal solutions. Now, one thing is for sure, there is no way you can find the optimal solution. Because in realistic situations, you have such a large, huge search space. In your lifetime, you cannot find the best possible result to your query. But then that does not mean you don't find the result. You still find the result, but the goal is to find a good set of results to a query. If you cannot find the best, because you cannot find the best. But then, in order to find this good set of results to a query, you need to explore and exploit in an acceptable level, so that you get a good result to a query. And that is where this exploring is called the diversification, and exploiting happens to be called what we call the intensification. Now, what is the fundamental properties? Meta-heuristic strategies guide the search process. It helps you guide the search process. The goal is to efficiently explore the search space in order to find near optimal solutions. You know, a lot of people use the word optimization in today's terminology. Now, because I come from a background of operation research, what I mean as an optimization is when an algorithm is able to find the best possible solution. Only algorithm can be able to find the best possible solution only when it can evaluate all possible solutions. It can evaluate all possible solutions when it knows what are all possible solutions. Now, in today's scenario, forget about finding best, forget about evaluating, you can't even find all possible solutions. And if you cannot find all possible solutions, there is no way you can evaluate all possible. And since you cannot evaluate all possible solutions, there's no way you can claim the solution you have got is the best solution. So that's why today's optimization is not the classical optimization. Today optimization is you're optimizing a solution, but you may not get an optimal solution. So we are actually not talking about today's the global optimal solution. We are talking about various local optimal solutions and then trying to find which is the best amongst these local optimal to find your global solutions. Now, these local optimals are also not the local optimum solutions. They are solutions which are near optimal in the local search space. So techniques which constitutes meta-heuristic algorithms range from simple local search procedures to complex learning process. Meta-heuristic algorithms are approximate and usually non-deterministic. They are approximate. They never give you the global optimal solution. They give you a near optimal solution. They are non-deterministic. They are stochastic in nature. They are probabilistic in nature. They are not deterministic. They have some sort of a probability, some sort of a stochasticity into these algorithms. That because in real life also it is more stochastic in nature. There's nothing deterministic in real life. You know, if you talk about random numbers, today whatever random numbers we work with, they are called pseudo-random numbers. You never call them random numbers. The question is why you don't call them random numbers. If you talk about random numbers in a very layman perspective, you say that I cannot predict the next number. Then I can say that these are the random numbers. But you know, you can have a length of numbers which may be random, but after length, the same length may repeat again. Then suddenly it becomes deterministic. It is no more random. So that's why you try to call them as pseudo-random numbers rather than calling them as random numbers. So that is why sometimes, you know, the idea is they are more stochastic. Some sort of probabilistic, stochastic nature is there, which we come across in real life as well, where nothing is deterministic. So that is why meta-heuristics are very closer to what we come across in real life. And real life problems are mainly such problems where you cannot find the best possible solution, but you are looking for a good set of solutions to the problem. That's why you may go to any shopping place, but still you will find from your friend that somebody has got a better deal than you. But the reason is that your exploration, exploitation, and a different balance, and he had a different exploration and exploitation. And there may be somebody else who got better than both of you. That is also possible. So that totally depends upon how much explore, how much you exploit, and that balance has to be. So they may incorporate mechanisms to avoid getting trapped in confined areas of search space. As I said, that randomization enables you to move from one local search space to another local search space. So they do not confine yourself into a search space, particular local space. The basic concepts of meta-heuristics permit an abstract level of description. Meta-heuristics are not problem specific. It's not there is one meta-heuristic for one particular problem. Meta-heuristics may make use of domain-specific knowledge in the form of heuristics that are controlled by the upper level strategy. The domain-specific knowledge is required whenever you talk about using a meta-heuristics. Today's more advanced meta-heuristics use search experience embodied in some form of memory to guide the search. So there is a concept of experience that comes into form in the form of memory, and that memory enables you to maybe guide the search space. So when I talk about meta-heuristics, I come about nature. Now, nature has solved many such problems in meta-heuristics. I will talk about nature, and then I will talk about all such algorithms that come from nature. And there are various meta-heuristics, and all these inspired algorithms are meta-heuristic algorithms because they have a sense of search and randomization. That is very, very important. And nature is not. There is nothing better than the nature that explains this better. You talk about the evolution of man. There is some sort of a mechanism of the selection and the crossover recombination operator, and then the mutation, and then you have a new generation. So always there's a probability. There is, whenever you talk about evolutionary algorithms, there is always a probability that a good parent survives and produces better offspring. But that does not mean that all good parents survive. The probability is very high. Similarly, it says that a less fitter individual dies. It's not all of them die. The likelihood of a less fitter individual surviving is less. Does not mean all less fitter individuals dies. It's cases where fitter individuals dies and less fitter survives. So that type of stochasticity there is there in the nature, and that's why nature itself is more stochastic in nature. Nothing is deterministic. There's no certainty that a fitter will always survive and less fitter will always die. There's always a probability that the likelihood of fitter surviving is more and the likelihood of less fitter surviving is less. So we have this evolution of man, and that is what led to what we are popularly know the Darwin's theory of natural selection, where we talk about survival of the fittest and struggle for existence, and that is which was inspired certain algorithms in like genetic algorithms which were able to solve problems. Now there is something called gene. I don't know how many of you know what is meme. Gene is something which is a genetic structure. There's something called meme, which comes from the behavior you learn from the environment. Now, what I mean to say is, let us understand one thing. A carpenter can share his knowledge with another person who then gradually becomes a carpenter. Now, this he has not got from birth. He may not be a son of will come from a family of carpenters, but he has actually gained this knowledge from the environment. Now, that is what this meme is all about. There's something called gene, and there's something called meme. And meme also has this evolutionary process. A teacher, when he teaches a student, the student may not come from a teaching family, but then the student learns from a teacher and then becomes a teacher. This transfer of knowledge and this transformation is something called the meme, the behavior you learn from the environment. And the algorithms like mimetic algorithms that are also there, which enables you to solve such problems in nature. Then we come across ants. I'll be discussing them. How much time? Let me see. But ants are very interesting. You come across ants in places and you notice them. They're very, very small. They have this ability to have the balance of this exploration and exploitation in some way or the other. This ants have the balance in terms of you find these ants. They are something which inspires algorithms that can solve problems of this exploration and exploitation. Because ants explore the search space. They gradually explore the search space, and what gradually they do is they're all spread out initially. They're all spread out looking for food, and the best part is they are socially organized. They help each other because they believe in one statement which was given by Helen Keller, that alone we can do so little, together we can do so much. So they believe in that fact. So what they believe is that today I will be contributing, tomorrow somebody else will be contributing. That is how we all are going to survive. They are very tiny brain. Alone they are not intelligent. but they exhibit intelligence through the environment, and that is why they communicate through the environment. That communication actually is called asynchronous communication. That means it does not occur by one ant talking to another ant. It occurs through the environment. Now, how does it occur? Ants are searching for food. On the way back, some ants find food some day, some other ants find food some other day. The ants that find food, they on the way back, they lay a chemical substance called the pheromone. So that pheromone is an indicator that this, if any other ant follows that path on the pheromone, then he is likely to land up in a particular food source. So that type of behavior is there. So gradually, when you notice ants, you're always noticing ants when they are in bunch. They're moving all in a straight line, and they are in bunch, and they're moving towards the food source. Now, this behavior of ants, which is gradually dispersed, and this gradually then they converge and then decides the way of path. And this is what this exploration and exploitation is. Initially, ants are exploring, and then gradually they're exploiting. How they're exploiting is, once they have identified the paths that are leading to food source, then they're all converging to that path and exploiting the situation. And that is how they are looking for the best solutions to the problem. Now, algorithms have been inspired by this, and now has been used in problems in information retrieval. I will tell you about one bio-objective optimization problem where the idea was to minimize the information overload and minimize the navigation. Now, interestingly, if you visit a web page, then your idea is that you should be able to see good number of links on the web page. At the same time, and the one which you are looking for should come with the minimum clicks. So this is actually has been defined in literature as a bio-objective optimization problem, where you try to minimize the information overload. At the same time, you are trying to minimize the navigation links. So that such problems have been solved using ant colony optimization, where initially you are trying to explore and gradually you are trying to exploit. Then you see on the right hand side there are birds. The birds have a very different nature. They also communicate, but unlike ants, which communicates through environment, that's why we call such communications as asynchronous, and the terminology used for such communication in the case of ants is called stigmergy. This happens to be the asynchronous communication. And when you talk about birds, they are also flying, but at the same time, they are having that synchronous communication. Usually you find the birds flying in a V shape. Okay, interestingly, they never collide with each other. But at the same time, they are communicating. They're also looking for food. They're also either looking for food or a place of rest, but they are communicating. What they are communicating is the best solutions, the best places they have found for rest, each of them, and then they decide amongst themselves which is the best amongst them. Then gradually the one which has found the best amongst all of them tries to lead the flock of birds. Now this behavior of birds when they are flying and they are looking for food source or a place of rest has also inspired algorithms that talks about the exploration and exploitation of the search space. So what is happening is initially they are also moving in such a random fashion. So their inertia is taking in some direction. So that is what exploration is all about. And gradually what happened is after the birds are talking with each other, they are sharing some information with each other. Now that is making them drift from their original path. So with a certain level of friction, they are getting drifted to their original path. And that is where with exploration, they are also trying to have exploitation. So that trade-off is there in there. And this algorithms are very much relevant when you talk about information search, where you try to create an environment where you can explore, at the same time while exploring, you can exploit. Now this is again, now you can see at the bottom, there's something called bees. Bees have a very interesting characteristic nature. You only remember them when they sting you. But you don't know, they have socially organized. They have their honeycombs, which have their own dance floors inside the honeycombs. And then these dance floors, people may not be knowing, the dance floors are there inside the honeycombs. And what the purpose of a dance floor is, again, the bees travel distances, travel kilometers, look for flowers, for nectar, and they come back. So initially all bees are spread out. So they're all exploring the surface, and they come back to this honeycomb, and they perform dances to exhibit what type of food source, the quality of food source, the direction of food source, everything is exhibited through their dance. And they perform dances, and there are bees on the around the dance floor who watch their dances and then decide to get recruited by the bees who are dancing. What is this recruitment all about is the bee which has found a food source will recruit certain other bees and take them along with them to the food source to get the more nectar from the flowers so that they can create more honey. Now, this algorithms of talking about exploration and exploitation have their own impact in terms of finding the best solutions to the problem. So nature has inbuilt. Now, there is a fourth one is what you talk about the cuckoos. You know about cuckoos, which happens to be you remember cuckoos for their melody, how good they are melodious, but they have a brooding behavior. That brooding behavior comes from the fact that cuckoos never have their own nest. So usually they lay egg in the crow's nest, but just not like that. They identify the crow nest and find the eggs, where they can lay their eggs. How do they decide? They decide that their texture of their egg matches the texture of that crow's egg, so that the crow is not able to identify its egg from the cuckoo's egg. And gradually what happens is their egg hatch faster, so new cuckoos are born, and the first thing the new cuckoos do is throw the crow's egg outside the nest. And that type of behavior of searching for such nests where they can grow, and they are not able to identify from the host bird, has also inspired algorithms like the cuckoo search algorithm, which has been used to solve such problems of exploration and exploitation. So what I mean is that I work in this area where I have been using to solve such problems of exploration and exploitation, where you try to have this thing. Now, in there are very relevant problem which I have addressed is the one where you talk about buying e-commerce problems, where you are searching something, you are searching for an item you want to buy. Now, how do you find out? Now, the question is that somebody wants to develop a website, and he wants to develop a website in such a manner that when a user logins to the website, he wants to display the items that the user is most likely to buy. Now, this is a very interesting problem. It's not a simple problem. It's a very complex problem, because a website may be selling millions of items, but how do they find which set of items they should display to the user so that he buys? So this is a multi-objective optimization problem, because there are many factors that dictates a choice of a user. And then based on those factors, you decide what items to put on the web page. It can have multiple objectives. If one objective may be, you don't like to download, heavier files. You download lighter files. You want to have a good visualization. You don't have, visualization, as I said, entertaining is as good as information. Because entertaining makes you sustain in a web page, and information disperses and provides you that information, that data which you require. Now, that is the balance you need to keep. So, so what I wanted to say was, the type of problems these nature-inspired computing are solving is, when to solve. Now, any information search problem is also a similar problem, like requires search through many possibilities to find a solution. As I said, writing a query is one thing. Getting an answer to a query is a challenging task. Because the answer, the information, the data that can answer to the query is residing at multiple places. Now, how to find which the places from where you want to pick the data, so that your efficiency in terms of answering queries is very high. That is, you want to reduce the response time of queries. So that idea has to be addressed. So you are looking for such combination, where you can have so many possible combinations, out of which you are talking about certain combinations. That is where the situation is to be addressed. So it requires search through many possibilities to find a solution. Search through sets of rules for one set that predicts the ups and downs in the financial markets. The search space is too big. And whenever you talk about information retrieval, because it is talking about web, the amount of search space is too big. So there is no way you can find the best possible solution, but then you are looking for all possible ways to get solutions to the problem. Search won't return within our lifetime. That's why this Google, this search engine's ultimate goal happens to be that how can they display the required and relevant information in the first page itself? Because they know that the user, if he does not find the information in the first page, may lose interest in that search, and then he may move to some other competitor. So these types of problems are better solved using a parallel approach, can be used. So when do you use such algorithms? You use such algorithms when the search space is too large. Because when search space is too large, it is not possible to visit or find all possible solutions. If you cannot find all possible solutions, there's no way you can evaluate all possible solutions. And if you cannot evaluate all possible solutions, then there is no way you can claim that the solution you got is the best possible solution. So when the search space is too large, when there is no algorithm that can find you the best solution, then you need to find a good solution to a problem. Then you resort to such techniques for finding such good set of solutions to such problems. When the best solution is not necessarily required, either you don't want the best. I'm not looking for the global best solution. I'm looking for a reasonably good solution. So that is fine. I may go for such techniques which actually gives me a reasonably good solution, because these techniques do not guarantee. So none of these stochastic based techniques guarantee you the best, that they have got the best solution, or none of these can guarantee that the solution they have got is the best. But what they can guarantee is that they have tried and they have got a good set of solution to that. Approach to solving a problem not well understood. Now this is what the state of an art is. State of an art is, you can talk about it, but there is no way you can explain about it. Sometimes how to play a game. Everybody who knows how to bat cannot make another person bat the same way. He can tell you strike the ball like this, but other person will also strike, but he may not get the same results. If somebody is scoring well in a subject, if he studies this way, if he tries to tell you also study like this, he can only tell him, but there is no way to define it so that he can do a study and get the same result as he has. He can get a good set of results, but still not as the same. So this is all they are called approaches, where you do not either have, you cannot approach, your approach is not well understood, or you cannot describe it mathematically. Then how do you solve such problems? Thus, such algorithms can help you enable to solve such problems. So whenever you come across even problems of information search, sometimes we want the solution, but we are not able to define and mathematically formulate it. But then still we know that this is how we get the solution. But then, then such techniques can be used to solve such problems. Now, problems with many parameters in classical optimization, this is called goal programming, where you talk about multiple objectives. Now the point is, as I said, real life problems do not talk about single objective. Real life problems talks about multiple objectives, and when you talk about multiple objectives, and then most of the you can use this, you need to simultaneously optimize. But then there is one interesting constraint. There are concave problems, there are convex problems. When you talk about simultaneously optimizing, you have to ensure that these objectives are conflicting with each other, because then only you can find a good trade-off. If they are not conflicting, it's so difficult to find a trade-off. That means improvement in one leads to deterioration in another, or improvement in the other leads to deterioration in one. So if this type of conflicts are there, then it is much better, easy to find solutions to such problems. Now, one more relevant problem in this scenario is the traveling salesman problem, which is the most popular problem when you talk about whenever anybody comes with an algorithm, he first applies to this problem, to find out how. And then, this becomes a benchmark problem on which various algorithms are actually compared. Now, traveling salesman problem, if somebody is from a computer science area, he is very well aware of traveling salesman problem. It is all about a traveling salesman who wants to visit cities in such a manner that he visits every city at least and at most once, and come back to the original city. The ultimate goal is to minimize the cost. The cost may be in terms of distance. So idea is to minimize. But when you talk about the solutions he needs to explore, you have for 10 cities, it becomes 1,000 solutions. For 20 cities, it becomes 10⁻16 possible solutions of cyclic permutations, and 50 cities as 10. So forget, you can't find the best possible solution, because you know the number, but there is no way you know what are these solutions. And if you don't know what are these solutions, there's no way you can evaluate such solutions. And once you cannot evaluate, there's no way you can find the best possible solutions to such problems. So such algorithms actually have been usually classified into 4 categories. They are categorized as evolutionary algorithms, the swarm, and the bioinspired and other meta-heuristics. Now, evolutionary, I have already discussed. Genetic algorithm, evolutionary, which evolved, and that is, genetic algorithm is based on the Darwin's theory of survival of the fittest. But again, I talked about the memetic algorithms also, where you learn from the environment. If not from genes, you learn from memes. Then swarm algorithm. Now, swarm is a collective behavior. You have the collective behavior. It can be homogeneous, Then you talk about swarm, and if it is heterogeneous, you call it collective intelligence, something called heterogeneous behavior. When you come across situations, you like to have heterogeneity in terms of expertise when you have formed even a committee. When people of different groups are there, with different expertise are there, they are likely to contribute more as compared to if you try to have one expertise, because there is going to be a biased behavior. Suppose you want to have something, you will have somebody. If you want to have a division in a university, you will have somebody from social sciences, somebody from humanities, somebody from life sciences, computer sciences, IT, every place. Because if you try to only keep people from IT, then you are biased towards that. So this collective intelligence is expertise from different places, and how they are expertise at different places is used to solve such problems. The swarm is a collective behavior. When I say swarm is a collective behavior, I mean to say that individually they are not good enough. They may not be that intelligent. Intelligence itself is a very ambiguous word. It has its different meanings for different people. Intelligence has nothing to do with literacy or education. Anybody can be intelligent who knows how to solve problems. Now the point is, swarm is individually they may not be intelligent, but they are socially organized in such a fashion that together they exhibit that nature of intelligence. So that algorithms, as I already discussed, like the ants, like the bees, like the birds, cuckoos, and all these some of behavior. Then there is something called bio-inspired algorithms. Now, this bio-inspired algorithms are like, there's something inspired by biology, maybe the artificial immune system. You know that, in such scenarios, when antigens like viruses, then you are looking for antibodies that needs to be created. So whenever you have these antigens, you need to create antibodies, and so that you are able to cure it. So that is where, so there is something called artificial immune system that simulates the immune system, and algorithms are developed that simulates the immune system, and that enables you to solve problems in computer science, like the traveling salesman problem. Then there are algorithms like the bacterial foraging. How bacteria forages, for food. And that algorithms that have also become inspiration to several algorithms that solve computers that from real life problems. And there are some problems which are other meta-heuristic algorithms. Now, other meta-heuristic algorithms, if I talk about, is like, the algorithms that may not be exactly biologically driven, but like algorithms like annealing process. We know the annealing process is where the, annealing process in when we study, it is all about heating a metal. If you want to give a new shape to a metal, what do? You heat it in such a manner that you take it to the higher temperature where it is in a liquid form, and then gradually cool it. And then while cooling it, you give it a shape. Now, this process also is a meta-heuristic technique, because there is something called Boltzmann constant, where, because molecules are so volatile, so always, they will not have that stability, they will have that stochastic nature when they are. So it is so easy to mold it when it is in a liquid form, and gradually while cooling it, it becomes rigid and rigid and rigid. And once it becomes in a solid form, it is no more easy to mold, it becomes rigid. So those annealing process have also been simulated, and the algorithms like simulated annealing that have been used to solve such meta-heuristic techniques, which enable you to get this balance between the exploration and exploitation. So I will skip the individual techniques. I will go to some multi-objective, because that is very important when it comes to solving problems, because of the laxity of time. So I will talk to multi-objectives about that.
Yeah, so I think I can request participants, if they are having any doubts or
No, I
any questions, they can post, sir.
Okay, they can post. So now
Yes, sir.
let me talk about this multi-objective, this is where I will try to end. Now, multi-objective optimization, as I said, most of the real life problems are multi-objective problems, because the idea is of multi-objective optimization is to talk about addressing various objectives. And in real life, you hardly come with problems which only have a single objective. So you come with problems which may have multiple objectives. So multi-objective is the process of simultaneously optimizing two or more conflicting objectives subject to certain constraints. And whenever you talk about optimization problem, there is an objective which you need to optimize. Optimize means either minimize or maximize, and subject to certain constraints in terms of the values, certain constraints. Now we know that certain constraints are there. If the number of constraints are too less, the number of variables are too high, then you try to solve the dual problem. You try to formulate the dual problem and solve the dual problem. Unlike single objective optimization, the goal of multi-objective optimization is not to arrive at a single optimal solution. Because the goal is not to find a single optimal solution. The goal is to find the best trade-off solutions. As I said, trade-off solutions means in terms of, so as I said in the case of car also, I want to find a solution which a trade-off. That is, the cost is also acceptable and the comfort is also acceptable. Now that trade-off solution I'm looking forward to. Set of trade-off or compromise solution among multiple objectives. Usually approaches that have been used widely in case of multi-objective optimization has been the scalar-based approaches, the non-Pareto based approaches, and the Pareto based approaches. As I said, the web search algorithm where I talked about, minimizing the information overload and minimize the navigation. Now it's a bi-objective optimization problem. If you try to minimize the navigation, then information overload might increase. If you try to minimize the information overload, then your navigation may also increase. So they are conflicting in nature. But then you need to talk about how to solve. One is the scalar approach. What scalar approach is that if navigation is say F1 and information overload is F2 objective, then scalar approach says that associate some weight with them. You say W1 F1 plus W2 F2 is equal to the F. That is the objective. So in either case, you need to minimize both. But the point is that W1 F1 plus W2 F2, you try to translate the bi-objective optimization problem to a single objective optimization problem, and you have techniques that solve those single objective optimization problem. So now instead of minimizing F1 and F2 simultaneously, what you minimize F, where F is equal to W1 F1 plus W2 F2. That are scalar-based approaches. Let me talk about the algorithm. The method applies a prior preference vector and converts the multi-objective into a single objective by assigning different weights for the objective and try to find the single compromise solution. But once you translate a multi-objective optimization problem to a single objective optimization problem, then you solve it as any approach that solves single optimization problem. Drawbacks is, how do you find what is the weight? Why this difficulty in weight is that somebody who buys a car also, he wants a comfort, he wants a cost. But everybody has a different choice in terms of weights, how much importance they have for comfort and how much importance they have for cost. Somebody may have 0.4 for cost, 0.6 for comfort. Somebody may have 0.44 for cost, 0.56 for comfort. So that may vary. So how do you find a common generic weight for comfort and cost that caters to multiple users? So that becomes a very difficult problem when you use a scalar approach catered to varied users. So as I said, this is one of the problems I solved where we talked about the download time, the visualization code, and probability of selling. Now these are the things, and you solve it scalar. So you talk about download time into what W1, W2 into 1 minus Vs, and W3 into 1 minus Ps equal to F, and our idea was to minimize this F. So it is hard to find what is W1, W2, W3 because this may vary from one user to the other. So scalar problem has its inherent limitation in terms of the requirement of a prior knowledge of the weights, which is very difficult, and there is no knowledge of weights which can cater to all sorts of users. So you need to address situations like this using approaches that do not consider weights. That is how you solve this problem. It was hard to find this. So unlike scalar approaches, non-Pareto or non-scalar approaches do not combine several objectives into single objective, but apply the operators and address various objectives individually. There's one approach called vector validity genetic algorithm. What it does is, it tries to have a population of individuals, then divide the population. In case if there are m functions, m objectives, it divides the population equally into m parts. And then for each individual part, is evaluated using a particular objective. So there are m parts, and every part is evaluated with respect to the respective objectives, and then you use some selection mechanism. You try to create a mating pool, then you do some crossover mutation, and you generate a new population. So here we are not looking for some weights, because we don't require weights. But what the problem is that we are actually there's a speciation problem. What it says is that we are only looking for good individuals in every objective. And when you are looking for trade-off, never a trade-off usually does not occur between individuals who are good in one objective. Trade-off is always a balance of a good set of solution in one objective with a good set of solution in another objective. It will never have a balance with the best solution in one objective with a good set of solution in another objective. So what this approaches of Pareto-based approaches, non-Pareto-based approaches does is, it leads to generating solutions which are good for respective objectives, and then gradually you don't find a good trade-off solutions to the problem. So then there was something called Pareto-based approaches. So there is something called Pareto Optimality. The Pareto-based approaches apply the concept of Pareto Optimality in the search process. Selection of the solution is based on the concept of non-domination. So dominating means a solution dominates another solution. There can be solutions which are non-dominated with respect to each other. Suppose I'm looking for a person who can teach physics and mathematics. Somebody is very good in physics, does not know mathematics. Somebody is very good in mathematics, does not know physics. So keeping in mind that I want a person with both physics and very good in physics and very good in mathematics, these two solutions I cannot compare. They are non-dominated with respect to each other, because I cannot say that one solution is better than the other. The task of finding a one or more Pareto optimal solution. The Pareto optimality is based on the concept of non-domination. A solution X dominates a solution Y if it is better than Y in at least one objective and not worse than Y for any other objectives. A solution is Pareto optimal if it is not dominated by any other solution. So a solution is Pareto optimal if it is non-dominated with respect to all sets of solutions. That is, it is non-dominant. And you understand, non-domination is you cannot say one dominates the other. Both are good with respect to their subjects. Usually, any places, people are good with respect to the subject. Somebody is good in one subject, somebody is good in another subject. So you are looking for a person who's good in all subjects, then you cannot compare them, because if he is good in one, the other is good in another. So there is no comparison. So Pareto optimal front calls the Pareto optimal solutions. Now the most important objective of a multi-objective optimization is two. The two goals of a multi-objective optimization is one, to find these non-dominated solutions on the Pareto optimal front. That means all non-dominated solutions in the population first. Secondly is to find the diversity in these solutions. As I will again come back to the example of cars. If I want to have a solutions for customers of a car, my idea is to find the best set of solutions for every cost. But if only I find solutions for people who are looking for whose cost budget is 4 lakhs to 8 lakhs, then what about those people who have more than 8 lakhs and people who have less than 4 lakhs? So that means what happens is the solutions are dense between 4 and 8. So I need to spread out. So the diversity of solutions is equally important. So you need to have solutions who have budget of 2 lakh, 3 lakh, 4 lakh, 5 lakh, 6 lakh, 8 lakh, and every 9, 10, 11, 12, 30. So what happens is this creates a diversity in solutions. So the multi-objective optimization has two goals. One, to find these set of non-dominated solutions because they are equally good solutions, and at the same time have the diversity in these non-dominated solutions. So they are spread out on the Pareto optimal front. So that if they are spread out on the Pareto optimal front, they cater to good number of users. That is important. So there are algorithms like very popular algorithm on non-dominated sorting genetic algorithm by Kalyan Boy and Day. So you can go through this document, which is totally based on the Pareto optimality. So the summary is there was a great interest between researchers to generate such algorithms that find near optimal solutions in reasonable learning time. So as I said, optimal you cannot find. So you are looking for near optimal. These algorithms are search algorithms capable of looking for good solutions. The algorithm could be considered belonging to the category of intelligent optimization tools. So ultimate goal when you talk about this is to find wisdom from data, and that is what the ultimate goal is. To you are having data at the lowest level when you talk about the search process. You need to gather how relevant the data is. That is where importance of the data. That is where the knowledge information comes. You have various scores like precision and recall. They have their own, and then you have this F1 score. Precision recall, you are very much aware when you talk about either precision, when you talk about number of retrieved documents that are relevant, and when you talk about recall, you talk about number of relevant documents retrieved. And we know that recall is much difficult to find out because you don't know the total number of relevant documents there. So that processing has to be done in terms of finding the most important and useful documents out of the entire all sets of information that is available across the World Wide Web. And then you extract some knowledge. And the ultimate goal is knowledge should help the user in solving the problem, and that is where the wisdom comes. It's not the knowledge that is only displayed to the user. That knowledge has to also help the user being satisfied by what he required from the system and enable him to use it to solve his problem for which he actually posed a query. So the ultimate goal is still to find wisdom from data, but wisdom from data totally depends upon how much information is available and how much relevant information you are able to gather. Gathering such relevant information is a very difficult task because you have so much data available. How do you gather? You know that you cannot gather the best possible or optimal set of information to cater to user query. Still, you need to find a good set of information. How to gather, and therefore there cannot be a deterministic algorithm that can solve such problem, because there is no global optimal solutions to such problems. So you have to resort to the stochastic optimization, and one such techniques are meta-heuristic algorithms that enables you to solve such problems, which are usually multi-objective. So there are ways of solving such multi-objective optimization problems using meta-heuristic techniques, which actually finds the balance between the exploration and exploitation in the search space. So this is what I want to talk. So thank you very much.
Yeah. So actually, we have got just one question just now from the participant. Says, how can we realize multi-objective optimization in internet search scenario? I think so.
No, no. As I said,
Yes.
when it's all about. There is a search engine. You are a person who uses an interface to pose a query, but there is somebody who is going to answer to a query. It's not the
Okay.
user who will be solving the problem. It is the service provider who will be providing you answer to the query. Now, given the user past query preferences, there can be past query performances, there can be preferences of people who have been posing the same query, what type of interest they have, and then based on those, there are multiple objectives to address. What is the liking? What is, if there is some query which is a keyword? What all things that influence the decision to a query? What all factors have effect in terms of answer to the query? And then they're all you want to minimize. As I said, the issue of its download time, I said you minimize the download time. So somebody wants to get some item to buy, so he needs to understand that it should be easy to download. So that has its influence, because if it takes less time to download, people are likely to buy that item. The probability of selling such item is going to be very high. It should look good at visualization. So there are various factors that may influence some answer to a query, and these factors have to be optimized accordingly, and therefore these factors are actually addresses multiple objectives, and these multiple objectives have to be optimized. So any answer to the query is not based on your only question. It is based on various other factors that influence answer to queries, and that is what this does. YouTube is one of the biggest example. It's based on the recommender, the collaborative filtering, where you talk about getting answers to the query, but when you you ask for some lecture on, say, machine learning. So the first is some machine learning lecture, but along with that you may get a cookery lecture, you may get a lecture on something else, you may get a wildlife video. How come so much unrelated things come? Because at the back end there are multiple things that goes on, where you try to find out all the other users who have used this answer to the query, what all other things they have done, and therefore what all other things you may like to see, and that is how they provide you answer to the query. So sometimes the answers are not related to each other, but they are based on certain facts, which are based on certain memory that has been utilized to provide and compute the answers to the query. That is what
Yeah.
happens.
Yes, sir. So I think sir has correctly pointed out the different aspects. I think these are aspects basically may be related from the user's behavior during the search, or maybe during the this whole search interaction or whole search session. So that's other things which we can consider as an objective. So, sir, there is another question from the participant and asking that between recall and precision, which can be best to use for evaluating the diversity of the results?
No, that's why there is something called F1 score, which happens to be computing the harmonic mean between the precision and recall. So that's why people resort to F1 score, because very difficult to find the recall, because you don't know, because recall happens to be relevant documents retrieved upon the total number of relevant documents. So difficult to find out how many relevant documents are there. At the same time, precision is also, you're looking for, you can easily find precision in terms of, because you know the number of documents that are retrieved, and you can find how many of them are relevant. That's why you need to increase the recall and you need to increase the precision. But then the best one, that's why they have come out with the F1 score, which balances out both. So it takes a harmonic, you take an harmonic mean between recall, so it's twice precision recall upon precision plus recall, and that is what you have, this harmonic mean. And you compute these F1 score, which have that balance of precision recall, and then you try to compare algorithms based on this F1 score.
Yeah. Yeah, so I think we have done with queries. So we still wait for a few more queries from the participants. If we have some queries, so I request participant to they may enable their audio and raise the questions. Though we have around 15 minutes for those questions. If any participant is having questions, they can enable audio and share the questions, or maybe post the query into the chat box. Yeah, so we can wait for some. Yeah, so actually, we have actually planned this FDP by correctly pointing out the importance of user behavior. So that's what we have thought of, that because this is considering user behavior into the retrieval framework is one of the, I think, current direction or dimension for the information search research. So because now most of the search systems are somehow incorporating the user behavior or user interaction into the retrieval process or retrieval framework. So that's what is the theme of this FDP also, that how to model these interactions, user interactions, maybe in the form of objectives, maybe in the form of different retrieval measures or retrieval parameters. So that's what is the theme of this workshop. So because nowadays most of the systems are basically considering a human or human in loop actually. So that's the theme of this one, and we have planned different sessions to take care of this aspect of information search. So because nowadays we have just started hearing about human intelligence. So because till 2 to 3 years back it was like computational intelligence, data intelligence, and now we are facing a lot of these concepts related to human intelligence. And human intelligence means basically capturing these different behaviors of user, maybe before starting the search, or maybe during the search, or maybe after conducting the different searches. So sir has, I think, correctly pointed out that how basically this human interaction or interaction with the search system is affecting the overall results, affecting the different relevant results also. So I think sir has correctly pointed. Sir, we have one question or maybe query from the participant, that could it be applied in cloud computing field?
Again, it is all based on resources. How do you exploit the resources? How do you explore for resources and exploit for resources? Again, it has relevance everywhere, because still in cloud computing also it talks about the infrastructure less systems. So, but how do you capitalize on the resources that are available on the cloud? Either how do you use resource provisioning, scheduling, all these things are addressed using such problems, such techniques of meta-heuristics.
Right. So, sir, one question I have particularly related to this: how basically this overall evolution on data science. I mean, we are having a lot of from terminology, a lot of events, a lot of research related to this data science, maybe field or maybe area. How the evolutions in data science is affecting the overall, or maybe specific to information retrieval search. I mean, because we are considering information retrieval as a very specific area, very specific application area. So how evolution in data science is affecting the research or maybe the development?
No, because data science is more or less uh, talks about because of the advent of big data and the amount of data that is getting generated. Uh, One is because of the technology that is available to capture this data, store this data. Now the thing is, earlier in ID field, people were looking for data and they had the technology. But when they have now got enormous amount of data, but they don't have technology to support, neither they have algorithms to support, and that is why they started calling such data, which is which has its own characteristics like volume, velocity, veracity.
Right.
So they started calling it very complex, so it's difficult to exploit. Now the thing is, this data science has come because now AI also has picked up, because AI happens to be one area which is all the entire world is going talking about, because they all looking forward to exploiting this area of artificial intelligence, and that is why it is considered as the fourth industrial revolution. We started with steam engines, then electricity, then internet, and now AI. So now AI exposure, because again I say that huge amount of data, you need to find techniques that can exploit. And same is with information retrieval, because you talk about data and information retrieval which are mainly unstructured in nature, and usually you get this data from the World Wide Web. But then how do you how do you analyze? Because it's not all about, we had this data earlier also, but today that competitive nature has forced us to find ways to analyze it data in such a way, in a very faster way, that so that the response times are very high. So whosoever is able to do it better is going to be more lead the competition in the market. So that's why the industries are always looking forward to it. And there are other things, related to even this pandemics, where you have a lot of data getting generated. So people want to come out with analysis as early as possible, so that they can have these preventive and proactive measures to solve such situations. So that also is equally important. The faster you analyze, the better you prepare yourself, better you handle the situations. So that's why this data science has become of interest, because now you have data, but you don't know what to do with this. So you're looking forward to solutions and techniques that can be applied to solve problems using such data.
Right. So, I mean, we have one or two questions, three questions actually related to this only part, that if we have a diverse, different types of data, and now we are planning to have a retrieval system, a retrieval process. So how this, and naturally we have planned to solve this retrieval problem as a multi-objective. So how this diversity or maybe different type of data is raising a problem?
Definitely diversity itself is a very big problem, because one of the areas in databases is the semantic web, semantic heterogeneity problem, because the diversity is not all about the diversity. Even within the similar type of data, there is a lot of heterogeneity, and not maybe syntactic, but it is the semantic, which is also one area of concern in computer science field. And this still is a problem, active research area, where people are looking forward to how to integrate information from various places, which are not only different, even if they are same, how to integrate by addressing the semantic minority, which may be due to the homonyms and synonyms that may be there. So that again, that's why people are not talking, they have been using the term, the ontology based techniques for that, which is something which has come from the area of psychology. The ontology has its own perspective when you talk about solving such problems. So heterogeneity in data, that's why I say big data is not only all about volume, it has about variety also. Variety in terms of heterogeneity is not only in terms of structured and unstructured, it can be in terms of the voice, the video data, the audio data, and all these data which is there. So that also is another concern. That's why I said that, once the complexity of data increased, it became difficult for algorithms. So that's why this data science field is all about finding how to address these algorithms. Now, multi-objective is the problem-specific domain. It is not with the heterogeneity. Heterogeneity has to be addressed to solve the problem in terms of multi-objective. Because if I have a structured data, which is a unstructured data in the form of text, so first I have to make it usable in terms of prepare it so that a technique can be used to solve such problems. So there is one area of data organization, data preparation, and then you talk about something techniques that are data science, where you talk about solving such problems using methods using AI. Yes.
Yes. So so thank you, sir. For actually, there is one question related to image retrieval. So suppose we have image-based data or databases which is having maximum files or docs in the form of images. So how we can plan for the retrieval of the images? I mean,
Again,
by considering multi-objective, sir.
Again, all data has metadata associated with it.
Yes.
Now, the data, as I said initially, information retrieval is not all about retrieving data within a document. It is document and even the metadata. Now, in case of images, metadata is also of great use in terms of retrieval. So metadata can be one, and the other is nowadays this image face recognition problems are addressed, but that is the image processing area. That is where you consider the image and use it for processing further. So that is another area of research where you use nowadays new deep learning techniques like convolution neural networks, recurrent neural networks have come up to solve such problems. But again, I said, it is not only data in a document, it is document as well as metadata also. That is can be of great help when you talk about retrieving information.
Yes.
That's why, there is very interesting example earlier. Whenever I talk about data science, I talk about an example of a photo. If you put there on web, earlier people were only interested in photo. Now they want to get into the metadata to find out details about the photo, where it was taken, what time it was taken, so that they have more information. So that curiosity has also enabled people to get into the metadata rather than only sticking themselves to data. Okay.
Yeah, in fact, one thing I want to share, I mean, recently we have got reverse image search also. So I think it is also based on how we can utilize the metadata of an image to identify the root of an image. I mean, because for a particular image, we are getting different variation of the image. So by utilizing these metadata informations, we can establish or design actually image retrieval system. So, okay, so we have not any other question left with us, sir. So I think we can conclude the session, and I would like to share greetings or thanks from my side, from NIT Kurukshetra Computer Science Department side, and from the participant side to share for sharing these information or different possible dimensions of using multi-objectives as a tool to solve the any kind of retrieval system or retrieval search scenario or research retrieval problems. So thank you for these knowledge and information with us, sir. We would be connecting with you, sir, for the next kind of events, which will be based on these two main aspects, which is machine intelligence and retrieval systems or information retrieval systems in the future also, sir. Thank you very much, sir, for connecting with us.
Thank you. Thank you.
Yes.
Best wishes to all of you. Thank you very much. Thank you.
Yes, thank you. So now I would like to make some announcements with the participant that we will be having the second session maybe by 12:30. So I expect each and every participant to connect to that session by using. We have shared this second. We have shared the different Google code for the second session, and second session we will be starting by 12:30. And this session is also one of the important session, because in that we will be having an expert from the industry, Dr. Lipikadi, and she is a principal scientist in TCS Innovation Lab. So we will be getting a lot of insights how industry is basically evolving, or how industry is looking at this field of machine intelligence for information retrieval. So I request each and every participant to be there on time so that we can finish or we can complete all these discussion within the given time, because we have scheduled this whole FDP in three sessions on a day. So it is better to be there in the session on time so that we can finish each and every session on time. And that's it from my side, sir. And whatever instruction we will be having for this FDP or the related to session, we will be naturally sharing maybe on daily basis.